our planet Earth. From the vastness of space, it appears as a serene blue marble, a beacon of life in the cosmos. But there's so much more to it than meets the eye. It seems so vast, so solid. The landscapes stretch out endlessly, with towering mountains and deep valleys giving an impression of permanence and stability. But beneath the surface lies a hidden world. A world that is constantly changing and evolving, driven by forces we can barely comprehend. A world of intense heat, immense pressure, and strange dynamic forces. Here, molten lava flows like rivers, and the ground beneath our feet is in a state of perpetual motion. This is the Earth's interior, a place of mystery and wonder. Scientists have only begun to scratch the surface of understanding what lies beneath. It's a place that holds the key to understanding our planet's past, present, and future. Ancient fossils tell tales of life that once thrived, while volcanic eruptions and tectonic movements shape the world we live in today. Think of it like an onion. Each layer of the Earth reveals a different chapter in its history, each with its own story to tell. Earth has layers, just like an onion does, from the crust we walk on to the mantle beneath and all the way to the core. Each layer is unique and fascinating. Each layer has its own unique properties. The crust is made up of various rock types, the mantle is a hot semi-solid mass, and the core is a dense metallic center. Join me on a journey to the center of the Earth. We'll explore these layers, uncovering the secrets that lie hidden beneath our feet. We'll uncover the secrets of these layers. From the surface to the core, we'll delve into the mysteries that make our planet so unique and extraordinary. Let's start with the outermost layer, the crust. It's the ground beneath our feet, the rock we climb on. It seems incredibly thick, right? But compared to the rest of the Earth, the crust is surprisingly thin. Imagine the Earth as an apple. The crust would be thinner than the apple's skin. The crust is made up of different types of rocks. There's granite, basalt, and many more. These rocks are constantly shifting and moving. These movements can cause earthquakes and volcanoes. Below the crust lies the mantle. This layer is not just a simple, static part of our planet. It plays a crucial role in the dynamic processes that shape the Earth. The mantle is a vast region that extends from the bottom of the crust to the outer core, encompassing a significant portion of the Earth's volume. This is the largest layer of the Earth. It makes up about 84% of Earth's total volume. Imagine the sheer scale of this layer, stretching thousands of miles beneath our feet. The mantle's immense size and mass have a profound influence on the planet's geology and tectonic activity. It's about 1,800 miles thick. To put that into perspective, that's roughly the distance from New York to Denver. This incredible thickness means the mantle contains a vast amount of material, all of which is under immense pressure and heat. The mantle is made up of hot, dense rock. These rocks are primarily composed of silicate minerals, which are rich in iron and magnesium. The temperature in the mantle can range from about 500 degrees Celsius near the crust to over 4,000 degrees Celsius near the core. But this rock isn't solid like the crust. Instead, it behaves in a plastic-like manner. This means that while it is solid, it can flow very slowly over geological timescales. This flow is crucial for the movement of tectonic plates on the Earth's surface. It's more like a very thick syrup. This viscosity allows the mantle to flow, albeit very slowly. The movement of the mantle is driven by heat from the Earth's core, which creates convection currents that circulate the semi-molten rock. This semi-molten rock is constantly moving. Imagine a lava lamp. Just as the wax in a lava lamp rises and falls due to the heat from the bulb, the mantle's material moves in a similar fashion. This movement is a key driver of plate tectonics. The heat from the bulb causes the blobs of wax to rise and fall. In the mantle, heat from the Earth's core causes the semi-molten rock to rise and fall in a similar manner. This process is known as mantle convection and is essential for the movement of tectonic plates. The mantle works in a similar way. The convection currents in the mantle are responsible for the movement of the Earth's lithospheric plates. These plates float on the semi-molten mantle and are constantly being pushed and pulled by the underlying currents. Heat from the Earth's core creates convection currents in the mantle. These currents are driven by the temperature difference between the hot core and the cooler upper mantle. As the hot material rises, it cools and eventually sinks back down, creating a continuous cycle of movement. This movement is incredibly slow, but it has a huge impact on the Earth's surface. Over millions of years, the movement of the mantle has shaped the continents, created mountain ranges, and caused volcanic eruptions. The mantle's mighty grip is a fundamental force in the ongoing evolution of our planet. Deeper still, we reach the outer core. Here, temperatures soar to over 9,000 degrees Fahrenheit. The intense heat melts the iron and nickel that make up this layer. The outer core is a place of constant motion. The molten metal churns and flows. This movement creates electric currents, and these electric currents generate a magnetic field. This magnetic field surrounds the Earth. It protects us from harmful radiation from the sun. Section 5, the inner core, a solid mystery. At the very center of the Earth lies the inner core. This core is a fascinating and mysterious part of our planet, shrouded in both extreme conditions and scientific intrigue. This is the hottest part of our planet. The temperatures here are beyond anything we experience on the surface. Temperatures here can reach over 10,000 degrees Fahrenheit. To put that into perspective, that's more than 5 times hotter than the hottest lava flow on the surface. That's hotter than the surface of the sun. The sun's surface temperature is around 9,932 degrees Fahrenheit, making the inner core even more scorching. But even though it's incredibly hot, the inner core is solid. This might seem counterintuitive because we often associate extreme heat with melting. Why? Because of the immense pressure. The pressure at the core is so intense that it overrides the high temperatures. The weight of the entire planet is pressing down on the inner core. This pressure is equivalent to about 3.6 million times the atmospheric pressure at sea level. This pressure is so great that it forces the iron atoms together. The atoms are packed so tightly that they can't move freely. They can't move freely to form a liquid. Instead, they are locked into a solid structure, creating a solid inner core despite the extreme heat. Scientists study the inner core using seismic waves generated by earthquakes. These waves travel through the Earth and provide valuable information about its internal structure. By analyzing how these waves change speed and direction, researchers can infer the properties of the inner core. This helps us understand not only the core itself, but also the dynamics of our entire planet. The inner core also plays a crucial role in generating Earth's magnetic field. The movement of molten iron in the outer core creates electric currents, which in turn produce magnetic fields. These magnetic fields combine to form the magnetosphere, which protects our planet from harmful solar radiation and cosmic rays. Without the inner core and its contribution to the magnetic field, life on Earth as we know it would be vastly different. The auroras we see in the polar regions are a beautiful reminder of this invisible shield. The inner core remains one of the most intriguing and least understood parts of our planet. Ongoing research continues to uncover its secrets, helping us piece together the complex puzzle of Earth's interior. As we delve deeper into the mysteries of the inner core, we gain a greater appreciation for the dynamic and ever-changing nature of our planet. Section 6, Earth's layers. A recipe for disaster? These layers might seem separate, but they're all connected. The movement of the mantle, for example, drives the movement of the tectonic plates. And the interaction between the outer core and the mantle generates the Earth's magnetic field. These interactions can sometimes lead to natural disasters. Earthquakes, volcanoes, tsunamis, all are a result of the dynamic forces at work within our planet. Section 7, and the magnetic field, our planetary shield. The Earth's magnetic field is essential for life. It acts as a shield, deflecting harmful radiation from the sun. Without it, our atmosphere would be stripped away. The surface of the Earth would be exposed to the sun's deadly rays. This magnetic field is generated by the movement of molten iron in the outer core. It's a powerful reminder of the incredible forces at work deep within our planet. Section 8. Exploring the depths, a continuous quest. We've learned a lot about the Earth's interior, but there's still so much we don't know. Scientists continue to explore the depths of our planet. They use seismic waves to study the Earth's structure. They drill deep into the crust to collect samples, and they develop new technologies to understand the extreme conditions of the Earth's interior. Section 9, Unveiling Earth's Secrets, A Journey for All. The journey to the center of the Earth is a journey of discovery. It's a journey that takes us to the very heart of our planet, and it's a journey that reminds us of the incredible power and complexity of the natural world. So next time you look at the ground, remember this: there's a whole lot more to Earth than meets the eye.